To make these ideas concrete, imagine a simple web application deployed for a mid-sized business. It handles customer interactions, data entry, and analytics. The workload runs across front-end web services, an application layer, and a database. The design must balance cost, security, performance, and resilience. This example acts as a mirror for nearly every project. Start small, grow safely, and automate wherever possible. The baseline includes an Azure App Service for hosting, an Azure SQL database for storage, Application Gateway for secure access, and Azure Monitor for visibility. Around that core, you'll see how every concept in this series applies, from identity to disaster recovery, working as one system. Identity always comes first in Azure. Using Microsoft Entra ID, the organization defines users, groups, and service principals. Role-based access control, or RBAC, assigns least privilege at resource group and subscription levels. Developers get contributor roles within their sandbox, operators get reader access across production, and automation identities receive only the permissions needed for deployment pipelines. Conditional access and multi-factor authentication protect sign-ins, while managed identities remove hard-coded secrets. This setup ensures that every action in Azure can be traced to a verified identity and that no process runs with unnecessary power. Identity management becomes the invisible foundation for every subsequent layer. Network design forms the next building block. The team creates a virtual network divided into subnets for front-end, application, and data layers. Network security groups control inbound and outbound traffic at each boundary, and private endpoints secure communication with databases and storage accounts. Azure Firewall, or Web Application Firewall, protects the perimeter, while routing rules ensure that management traffic flows through approved gateways. Peering and DNS configuration connect environments without flattening them into a single trust zone. This structure respects zero trust by assuming that no segment is inherently safe. Networking is both the map and the moat. It defines how everything talks and who listens. Storage choices balance accessibility, performance, and redundancy. The team selects storage accounts with tiered options: hot for frequently accessed data, cool for archival content, and zone-redundant storage to protect against hardware failure. Blob encryption and access tiers are enforced by policy. Private endpoints prevent public exposure, while lifecycle management rules move old logs to lower-cost tiers automatically. Encryption keys are managed in Azure Key Vault, ensuring that even backups meet compliance. These design patterns demonstrate that storage is not just about capacity. It is about trust, efficiency, and predictable performance over time. For compute, the rule is platform as a service before infrastructure as a service. The web app runs on Azure App Service, gaining automatic scaling, patching, and load balancing without managing virtual machines. The database uses a managed PaaS tier for updates and backups. Only specialized components, such as custom integration services, rely on containers or virtual machines. Choosing managed platforms reduces administrative overhead, improves security posture, and aligns with cloud-native principles. Infrastructure as Code provisions these resources consistently, ensuring that development, staging, and production remain identical in structure, differing only in parameters like region or size. Security layering follows the zero-trust model we explored earlier. Identity verification, device compliance, network segmentation, and encryption work together to prevent unauthorized access. Microsoft Defender for Cloud monitors vulnerabilities and applies baseline recommendations. Conditional access policies adapt authentication based on context, while data classification in Microsoft Purview ensures sensitive information receives the right protection. Logs feed into Sentinel for threat detection and correlation. Security is not a bolt-on feature. It is baked into each layer. This defense-in-depth approach assumes breach, verifies explicitly, and minimizes privilege, creating resilience by default. Governance ensures order and accountability as the environment grows. Tags track ownership, cost center, and environment. Resource locks protect critical assets like production databases from accidental deletion. Azure Policy enforces standards: only approved regions, encryption required, and diagnostic settings enabled. Policy initiatives group these rules for simpler assignment. Over time, governance frameworks evolve into living code, deployed and updated automatically through landing zones. With governance codified, new projects start secure and compliant from day one instead of relying on post-deployment reviews. Observability ties operations together through Azure Monitor, Application Insights, and Log Analytics workspaces. Dashboards show latency, throughput, and error rates alongside platform metrics. Alerts trigger action groups that notify engineers or automation runbooks when thresholds are breached. Traces link user transactions from the front end through the database, providing full visibility across layers. Regular workbook reviews help teams refine alert logic and remove noise. Observability makes the environment transparent. It turns behavior into evidence and evidence into improvement. Without it, optimization and security become guesswork. Cost levers ensure that efficiency accompanies capability. The team applies reservations for predictable compute workloads and savings plans for long-term consistency. Scheduled automation shuts down development environments during off-hours, and right-sizing reviews adjust resource tiers based on performance data. Cost analysis dashboards tag expenses to departments, creating accountability and driving cultural awareness of consumption. Azure Advisor recommendations and budgets provide guardrails, while policies prevent accidental overspending. Cost management, when integrated from the start, turns cloud finance from a surprise into a strategy. Resilience comes through deliberate redundancy. The app deploys across availability zones within one region for local fault tolerance and uses a paired region for disaster recovery. Backups run automatically and replicate to secondary storage with immutability. Regular drills verify restore times and failover accuracy. Traffic Manager can reroute users if an entire region goes offline. This layered design accepts that failure will happen and plans for it explicitly. The payoff is business continuity under stress, a hallmark of well-architected cloud systems. DevOps practices bring speed and safety together. Infrastructure as code, through Bicep or ARM templates, defines the environment declaratively. Continuous integration and deployment pipelines automate builds, testing, and promotion between environments. Blue-green deployment patterns minimize downtime during updates by shifting traffic gradually. Rollbacks are scripted and reversible. Security scans and compliance checks run as part of the pipeline rather than after release. This workflow enforces consistency, reduces risk, and encourages collaboration between developers and operations. DevOps in Azure is not just tooling, it's the practice of turning change into a controlled process. Operations in the steady state require rhythm and hygiene. Teams hold regular operational reviews, examining health dashboards, cost trends, and policy compliance. Logs are trimmed, expired, or archived according to governance rules. User access is recertified, and automation scripts are tested for relevance. Continuous improvement cycles capture lessons from incidents and feed them into runbooks or automation updates. Over time, this discipline builds reliability and predictability. Healthy operations are quiet because every process alerting, patching, reviewing is routine rather than reactive. Operating confidently in Azure means seeing the platform not as a collection of services, but as an ecosystem guided by principles. Identity anchors control. Networking shapes reach. Storage preserves integrity. Compute delivers function. And governance ties everything together. Observability confirms that what you built works as intended, and optimization ensures it stays sustainable. When each of these parts reinforces the others, you achieve clarity, knowing that every workload is secure, efficient, and ready to recover. The cloud is complex, but with these disciplines working in concert, Azure becomes not just a platform you use, but an environment you truly understand.